Hey guys, in one of my previous videos I have discussed about the NTPC exam pattern and also the syllabus. Today in this video I'll be discussing about the important areas of each topic that you should concentrate or focus for the exam. So the exam will be for 120 minutes guys, and the number of questions are also 120. So for each question you get 1 minute to solve, and the level of the question will be very basic. All the questions are asked from the basic level only, so please concentrate on basics of both inter as well as degree. So they'll be covering only this two, that is only this inter level and degree level basics only. And also the very important thing here is you should be very good at anomalies also guys, that is exceptions. So be good with exceptions also, and also cover the basics. That's it. So in this video I've covered all the important areas from each topic, that is physical chemistry, inorganic chemistry and organic chemistry. So I've covered the areas of each topic so that you can expect a definite question from these topics. Firstly, coming to the physical chemistry. In physical chemistry, firstly it is atomic structure guys. So atomic structure, the basics are enough, and I made a video on this atomic structure. That is, I've just made a video on formulas of atomic structure. You can just go through it. That is enough, completely enough. In states of matter, the important areas that you should cover are gas laws, ideal gas equation, Graham's law of diffusion. Here comes the important areas, that is kinetic gas theory, that is kinetic theory of gases, RMS velocity, the most probable velocity, the average velocity, van der Waals equation, viscosity, and solid state, basics of solid state. So you can expect a definite question from kinetic theory of gases, or RMS velocity, or the most probable velocity, or the average velocity, or van der Waals equation. And you can expect question from the van der Waals constants also, and solid state basics. So these are the important areas that you should cover from states of matter. Coming to chemical thermodynamics. In chemical thermodynamics, you should cover intensive and extensive properties, examples, units like they'll be asking direct units of enthalpy or specific heat, that is Cp or Cv, and heat capacity, work done in reversible and irreversible isothermal expansion. And here comes the important one, that is Joule-Thomson effect. Many questions will be asked from entropy guys, so you should be very perfect with entropy. Be good with all the questions of entropy and Gibbs free energy, Maxwell's relations, heat of combustion. I'll just roll it down. And then heat of formation, second and third law of thermodynamics, and efficiency of heat engine, and also chemical potential. So these are the important areas that you should cover. And here comes this ionic equilibrium. In ionic equilibrium, Ostwald dilution principle is important, common ion effect, and also solubility, definite question from solubility product, and also ionic product. Next is chemical equilibrium guys. So in chemical equilibrium, Van Hoff reaction isotherm is important, and also Kp, Kc. Especially you can expect a definite question from Le-Chatelier's principle guys. So be good with Le-Chatelier's principle. Coming to redox reactions. In redox reactions, the important areas are disproportionate and proportionate reactions. So the question will be like, they'll just give an equation and ask whether the equation is proportionate or disproportionate. And sometimes they'll be asking this oxidation numbers also from the equation. And next is phase equilibria. From phase equilibria, the important area is only one area, that is calculation of degree of freedom, or just concentrate on this triple point guys, that is the triple point of water. And there is this very important examples of non-ideal solutions which shows positive and negative deviation from Raoult's law. Okay, the examples are like mixture of solutions. This area is from intermediate. There are many questions from this area in intermediate, that is +2 level. And coming to the formulas, that is formulas of molarity, normality, mole fraction, strength of solution, ppm. So these are from solutions, guys. So these areas are from solutions. Please do concentrate on these areas also. And coming to electrochemistry, in electrochemistry, Faraday's first law and second law. This is important. You can expect a question from Faraday's first law and second law. Arrhenius theory of electrolytic dissociation, specific conductance, equivalent conductance, cell constant, Kulroch's law and equation. You can expect a question from Kulroch's law and equation. They'll just ask the equation directly, or in the form of graph also. And electrochemical series, this is also important. Galvanic cell, this one, and electrolytic cell, EMF calculation, this is also important, guys. And also Nernst equation, this is also important. Ionic strength, de Broglie-Onsager equation. So in this also they'll ask the equation directly or in the form of graphs. So if you're good with equation, you can just do graphs easily. And then coming to chemical kinetics, units of rate constant, that is first order, second order, third order, and finding out the order of the reaction, zero order, first order, and second order. This is second, guys, sorry. Yep, this is second order examples. And finding out K, that is rate constant, and T half, and I'll just roll it down. Yep. And effect of temperature and catalyst on rate of reaction, Arrhenius theory. So these are the important areas from chemical kinetics. And then comes nuclear chemistry. In nuclear chemistry, properties of alpha, beta, gamma rays, N by P ratio, finding out N by P ratio, number of alpha particles and beta particles, T half, disintegration constant, units, mass defect, dimensions of atom and nucleus, binding energy, packing fraction. So this is different from solid state packing fraction, guys. So these both are very different. And then comes surface chemistry. In surface chemistry, physics option, chemist option, Friedrich adsorption isotherm, and Langmuir adsorption isotherm, and also Bet adsorption isotherm. I hope you could see this. Yep. So Langmuir adsorption isotherm and Bet adsorption isotherm. So these are the important areas from physical chemistry, guys. In inorganic chemistry, from mole concept and stoichiometry, the important areas are calculation of number of moles, finding out oxidation numbers, and stoichiometry. And coming to periodic table, in periodic table the trends of atomic radii and ionization potential are important, and also the calculation of electronegativity according to Millikan and nature of hydrides. So basically the concept of electronegativity is very important. So be perfect with all the areas of electronegativity, guys. And here comes the very important topic, that is chemical bonding. So from chemical bonding, all these areas are very important. You can expect a definite question, that is, all the from molecular orbital theory or Poisson's rules or Vesper theory, calculation of formal charge, dipole moment, and hybridization. All these areas are very important. If not for NTPC, these are very important for any other entrance exams. And I'll just roll it down. And here comes the main group elements. In main group elements, borax, reactions with the H3BO3 and boron halides acidity, that is the principle involved here is back bonding, and diborane, borazine, properties of diamond, graphite, and fluorines. NTPC is all about thermal power generation, guys. So also include the properties of carbon compounds like coal, bituminous coal, peat, etc. Be good with all the carbon compounds like petrol, diesel also, and their calorific values. And then comes carbides, silicones and silicates, and carbon tetrachloride and silicon tetrachloride. It is also a conceptual question. So you can just go through this conceptual question: why silicon forms tetrachloride whereas carbon doesn't form? And here comes the Haber's process and oxoacids of phosphorus with oxidation numbers. And also this is also a conceptual question: not a conceptual question, but the compound that is formed with this reaction, that is the reaction between phosphorus and sodium hydroxide, it is the compound formed is very important. This is a repetitive question in +2 level. And also oxacids of sulfur with their oxidation numbers, and boiling point of hydrides of oxygen family, halogen family, and nitrogen family, and hydrogen bonding, oxacids of chlorine. So in from oxacids of chlorine, structure of the oxacids of chlorine is important, and the number of lone pairs in these structures are important, and also the hybridization. So and then comes interhalogen compounds, number of lone pairs and structure of polyhalides are important, and also the xenon halide structure, that is hybridization, is also important. Yep. In lanthanides, electronic configuration is very important, and lanthanide contraction, basicity, atomic radii, color of lanthanides. These are the important areas. And here comes the coordination chemistry. In coordination chemistry, IUPAC nomenclature, EAN, that is effective atomic number, is important. Isomerism, that is structural isomerism, and stereoisomerism is important. And also VBT hybridization, mainly focus on this nickel and copper complexes, guys. And spectrochemical series, and crystal field theory, and also CFSE calculation. All these areas are very important from coordination chemistry. And from coordination compounds, that is from coordination chemistry, factors affecting CFS is also important, along with John-Taylor distortion. And here comes the metallurgy. From metallurgy, all these concepts are very important with examples. So be good with examples of all these concepts, guys. And leaching, gravity separation, electromagnetic separation. The questions will be like, which of the following minerals undergo electromagnetic separation. So they might ask with examples, so be perfect with examples also along with these concepts. And froth flotation, calcination, roasting, flux, examples of flux, acidic flux and also basic flux, gang, slag, liquation, cupellation, polling, zone refining, and Ellingham diagram. Ellingham diagram, that's it. And here comes the bioinorganic. In bioinorganic, they'll be asking very basic concepts, guys. That is, the metal present in hemoglobin, or the metal present in chlorophyll, etc. So the concepts will be very easy. So from bioinorganic, hemoglobin, myoglobin, hemerythrin, hemocyanin, metals present in metalloenzymes, photosynthesis, diseases caused due to metals. So these are the important areas of bioinorganic, guys. And this is all about inorganic chemistry for NTPC. In organic chemistry, from basics of organic chemistry, IUPAC nomenclature, I've made a video on IUPAC nomenclature also. You can just go through it. Acidity, basicity, substitution reactions, that is SN1, SN2 or SNI, etc. And elimination reactions, that is E1, E2 and even CB. And then comes inter and intramolecular hydrogen bonding and isomerism. So for stereochemistry, in stereochemistry, finding out the configuration, that is RNS configuration, cis trans, EZ, and stereoisomerism, and also stereoisomers, finding out number of stereoisomers. And from alkanes, Wood's reaction, Colby's electrolysis, preparation of alkanes from Grignard reagent, syngas, natural gas, LPG and CNG, and their calorific values. The calorific values of syngas, natural gas, LPG and CNG are important, guys. And also the anti-knocking agent. They'll ask directly which of the following is an anti-knocking agent. Now that is nothing but lead tetraacetate. And this is all about alkanes. In alkanes, heat of hydrogenation, hyperconjugation, Seytzeff rule and Hofmann's rules, Markovnikov and anti-Markovnikov rule, Wagner-Mervin rearrangement, Lin-Last catalyst, pyrolysis of quaternary ammonium salts, hydrogenation, Bitch reduction, oxymercuration and demercuration, along with hydroboration. These areas are important, guys. You can expect a definite question from this area. Excuse me. And then comes Diels-Alder reactions and ozonolysis, Wacker's process, Ziegler-Natta catalyst, hydroxylation reactions, with the help of potassium permanganate and osmium tetroxide. And coming to halogens, I'll just roll it down. Yep. In halogens, the role of NBS, N-bromosuccinimide, and the halogenation in the presence of UV light, and also the reactions involving trichloromethane, that is Riemann-Tiemann reactions, carbalamine reaction, iodoform test for halogens. And then comes oxygen containing compounds, that is alcohols or aldehydes or ketones. So in alcohols, the test for alcohols is with the help of Lucas reagent and isomerism, addition of Grignard reagent to aldehydes and ketones, oxo process, pinocol-pinoculone rearrangement, dehydration of alcohols, potassium permanganate, hydroxylations, and chromium-6 reagents, Oppenauer oxidation, Williamson synthesis, action of hydrogen iodide on ethers, haloform reaction, reduction reactions, that is Clemmensen and Wolff-Kishner reductions, Clemmensen reduction and Wolff-Kishner reductions, test for aldehydes and ketones, Wittig reaction, Cannizzaro reaction, aldol condensation, benzoin condensation, benzyl and benzylic acid rearrangement, Favorsky rearrangement, and Elsted reaction or rearrangement. And then comes nitrogen containing compounds. This is important, guys. Gabriel Thalmide synthesis, Hoffman rearrangement, Curtius rearrangement, Lawson, Smith and Beckman. All these are very important from nitrogen containing compounds. And then urea and malonic ester. So in urea and malonic ester, hydrolysis of urea, action of heat on urea, reaction with nitrous acid are important. Sometimes generally they'll ask direct question like what is the formula of urea or malonic ester. Directly they'll ask questions. And coming to reaction of alpha beta unsaturated carbonyl compounds. So from this area you can expect a reduction question, reductions with lithium aluminum hydride or sodium borohydride, etc. And next, polymers. Polymers is very easy. They'll be asking just examples like which of the following is a thermosetting polymer, that is nothing but bakelite. These kind of examples, just basics from intermediate. These are more than enough, guys. And coming to IR, UV and NMR spectra, in these areas also basics are enough, because for each question you just have 1 minute, so they won't give you all the depth questions. So basics are enough from spectra. And then from these areas, from biomolecules and environmental chemistry and chemistry in daily life, you can expect a definite question. And from biomolecules, amino acids, carbohydrates and vitamins are important. And from all these are from intermediate level only. They'll be asking only the intermediate level questions from biomolecules and also environmental chemistry and chemistry in daily life. In this area, COD, BOD, that is nothing but chemical oxygen demand or biological oxygen demand. Disaster, that is man-made disasters like Bhopal gas tragedy, and which gas is involved in Bhopal gas tragedy, etc. And you can expect a definite question from greenhouse effect, which of the following is a greenhouse gas, etc. And that's it, guys. I've given you a brief explanation of all the topics, and it's up to you. Prepare wise and keep going, keep practicing, keep encouraging. All the best, guys. Thank you for watching this video.